All right, we're going to start out with solving some square root equations here. Square root equations, hence the name. Obviously, there is a square root in the equation. Now, I'm going to do these examples, but I want you to remember the basics of solving any equations. We're always using inverses or opposite operations. So if you had a very simple equation like 3x plus 2 equals 14, we all know we go minus 2, leaves us with 3x equals 12. Divide by 3, divide by 3. X ends up equaling 4. We're using opposite operations. The opposite of plus is minus. Do it to both sides. The opposite of multiply is divide. Do it to both sides. So the first thing we have to remember is if we're going to solve this is what is the opposite of a square root. The opposite of a square root is a square. We're going to do it to both sides, the same thing. Deal with the square root. Square both sides. So this square root and this square cancel each other, leaving us with 2x. 6 squared, please don't say 12. 6 squared is 36. And if you need to, scribble those out. Not necessary, but if you want, show the square and the square root cancel. Now, how do we get rid of 2 times? Divide by 2, divide by 2. Hope you don't need a calculator for this. 36 divided by 2 is 18. All right? So we're going to be dealing with that square root. Now, I didn't go ahead and state it, but in general, we want to get this square root by itself. The first few problems, I already have them by themselves. So the second example, the square root of negative 3x plus 1 equals 5. Square it. Square it. Those cancel out. Negative 3x plus 1 equals 25. I think from here it's pretty much old hat. Minus 1, minus 1. Negative 3x equals 24. Divide by negative 3, divide by negative 3. I'm just using opposite operations. Not trying to complicate things here. Positive divided by a negative. 24 divided by 3, 8. All right? Now, we've got these answers. There is one thing that I should say, and I didn't bother doing it because for the linear ones, we never run into an issue. When you have x equals 18, we should take a moment and put it back in just to check and make sure there's not a problem. So 2 times 8, so you got the square root of 2 times 18 equals 6. Just putting it back into my original. The square root of 36 equals 6. That's a true statement. So we're good on our check. Here, negative 8. Put it back into the original. I'm going to do a little erasing here because I've run out of space. Negative 3 times negative 8 plus 1, all in the square root. I put that negative 8 back in there. Does that equal 5? Negative 3 times negative 8, positive 24 plus 1, square root of 24, square root of 25 is equal to 5. We're good. That checks out. All right. What do you do if you have 2 square roots? Luckily, they're both by themselves. So we square both sides. We square it, we square it. Both square roots will cancel. X plus 5 equals, started to write the square root for some reason, 2x minus 7. All right? So, got the x's on both sides. I'm kind of a don't worry about left or right, get rid of the smaller one. So minus x, 5 equals x minus 7. Add 7 to both sides. 12 is equal to x. Take that 12, put it in for both of them. So the square root of 12 plus 5 equals the square root. 2 times 12 minus 7. Square root of 17. 2 times 12, 24, minus 7. The square root of 17. We check out, we're good. All right? Now, for example 4. The square root isn't by itself, is it? How do I get rid of plus 5? Minus 5 minus 5. The square root. 3x plus 4 equals negative 3. Now, I'm here to tell you, if you think about this, is it possible for a square root to equal a negative number? It's not possible. We already know this is no solution. Can somebody get that door? We already know that. But I just want to take a moment and still go through the methods or the procedure. Okay? We're going to still square both sides because I want to show you what happens here. The square root and the square cancel out. 3x plus 4. Negative 3 squared. That's positive 9, isn't it? So I'll go minus 4 minus 4. 3x equals 5. Divide by 3. Divide by 3. X equals 5/3. We actually, by doing our methods, get an answer for something we know should be no solution. All right? If you take a moment and put the 5/3 back in. So I got the square root of 3 times 5/3 plus 4 plus 5 equals 2. 3 times, put that over 1, the 3's will cancel. We end up getting 5 plus 4, that's the square root of 9. If that arithmetic lost you a little bit on fractions, don't worry about it. Plus 5 equals 2. The square root of 9 is 3 plus 5 equals 2. There is no world that I know of where 8 equals 2. So on our check, it doesn't work. It's no solution. All right? The very last one, I'm going to erase the check here so I have space. Kind of erase that now. We'll write it over here. No solution. All right. Now I've got a quadratic in here, don't I? Still over a square root. Square both sides. X squared plus 4x plus 4. 1 squared is 1. With quadratics, what do quadratics need to equal? 0. Thank you. Minus 1 to both sides. X squared plus 4x plus 3 equals 0. Now, you could use the quadratic equation. You could complete the square. By far the easiest way to do that is to factor. This factors very easily. What multiplies to be 3 adds to be 4. Plus 3 and plus 1. Set them equal to 0. Minus 3, x equals negative 3. Minus 1, x equals negative 1. Plug them back in. Let's make sure they are answers that will actually give us that. All right, so when we do our check, negative 3 squared plus 4 times negative 3 plus 4 equals 1. All of that's in a square root. Negative 3 squared, 9. 4 times negative 3 plus negative 12 plus 4. All in the square root. 9 plus negative 12 is negative 3 plus 4, positive 1. Is the square root of 1 equal to 1? It is. So the first number checks out. Check out the second one. I'm going to be a little lazy here. Okay. Put in a 1. Put in a negative 1. Negative 1 squared is 1. 4 times negative 1, negative 4, plus 4. That's in a square root. 1 plus negative 4 plus 4 is positive 1. Square root of positive 1. Oops. 1 is equal to 1. I wrote it a second time. Anyway, that's the basics. I know it went quick. Don't be afraid to pause it, rewatch it, and we'll go from there.